Identifying exponential functions. So exponential functions do not have constant rates. So we've been looking at linear functions that they have a constant rate of change. These have a constant ratio or a common factor. So whereas with a constant rate of change, we were looking for a common difference, here we're looking for a common factor. So we're going to determine whether each of these sets of data displays exponential behavior, and we're going to explain why. So here we have this table, and we're going to see what we have in common. First, it's always nice to start by checking the x values to make sure there is a nice pattern to our x values, typically a common difference. So here we're increasing by 1, so that's good. We have our x values at regular intervals, so we can actually check for a pattern with our outputs. And here we see we've got 3, 9, 27, and 81. Now, there's no common difference because I add 6, and then I don't add 6 ever again after that. However, I do notice that if I multiply by 3, I come up with the next output. So this is exponential because the data has a common factor of 3. There is a common ratio here. So my ratio as opposed to my common difference. So it doesn't have a constant rate of change. When we look at it on a graph, and that's what we're going to look at next, when we look at it on a graph, we realize this is not a constant rate of change. It's increasing and increasing significantly each time. So it's not a constant rate, which would give us linear. We do have a constant ratio, however, meaning I can take the last one and divide it by the one before that, and I'll always get a common ratio to that. So this is exponential. We can look at that as a table, or if we think of it like a graph, we can see what that graph would look like. Let's take a look at a couple more. So I have this table here. Again, I always want to start by making sure that my x values have a regular pattern to them. So they do, in this case, they're all got a factor, a common difference of 1. And then when I look at my outputs here, I notice these have a common difference also. So this is not exponential because this has a common rate of change. I could take my y over my x, come up with a slope. This would be nice and linear. So I don't have a common ratio here. I'm not multiplying each one by something to get that same thing. I'm not multiplying by the same thing every time, which is our exponents. I'm adding the same thing every time, which is our linear function. So no, this is not exponential because the data has a constant rate of change, 5 over 1. That is not exponential. Last one, let's take a look at this table over here. Again, let's check our x values, make sure our x values have a constant difference, that we have a nice pattern there, so that we can really look at what the pattern for the output is. And so when I look at my y values here, my range, I see that I don't have a common difference, but I do have a common factor. So when I multiply each of these by 1/2, I come up with the next output. So it is exponential because the data has a common factor of 1/2. So we can think about it from our table. If the output has a common factor, it is exponential. We can also think of it as our graph. If our graph has that increasingly steep slope to it, doesn't really have a slope to it, but as it gets steeper and steeper as it increases, doesn't have that constant slope to it, then we consider it exponential.